Hi everyone and welcome to JupyterCon. This talk will be about different JupyterHub pieces and how they fit together, making the magic happen. But first, who am I? The answer is not a JupyterHub power user. But then, why am I here? My name is Georgiana Dolocan and I am working as a JupyterHub and Binder contributor in residence under the CSEI Essential Open Source Software for Science grant. I discovered my love for Project Jupyter when I was an outreachy intern, working on developing an alternative for the configurable HTTP proxy, the traffic proxy. I had only used Jupyter Notebooks a few times back in college, so I wasn't a power user at all. I wasn't even a Python developer and only used it for scripting up until that moment. But after reading the project description on the outreachy page and meeting the Jupyter community members, I was irreversibly hooked and became fascinated about the project, about the community, and about open source in general. So, as you can imagine, I didn't know too much when I first started. During the outreachy contribution period, I heard for the first time terms like JupyterHub, configurable HTTP proxy, the notebook server, Jupyter Notebook, dummy authenticator, and the spawner. And later on, when trying to make sense of things, I bumped into Jupyter Lab. So I only knew a little something about the cute classic Jupyter Notebook. But what is to be done next? How and where do you start just knowing things? The answer is you start with patience and baby steps. A little more than 1.5 years later, I definitely know more things, but I still feel like I know very little. Especially when I come across parts of the project, of a project that I didn't know about or didn't quite yet understand. Not to mention that sometimes the very existence of a project surprises me. But it's okay to not know everything. And it's always fun to learn when you actually love the subject. But let's go back to those notions I mentioned in the previous slide. Are they part of JupyterHub? The answer is no, but at some level they represent an extension of it. The hub itself can be configured, but so are its components. So one could extend their hub at different levels in the architecture stack. This is fascinating and it's what gives the hub the ability to easily be included in many architectures, often without having to change or adapt new technologies. But all of this can be a little confusing at first. So let's put some more light on those first notions I mentioned at the beginning that were new to me. So both the Jupyter Notebook and the Jupyter Lab are called interfaces. They are web applications and basically are what we perceive as being the notebook. Unlike the classical notebook interface, Jupyter Lab shares some common features with traditional IDEs, but it still remains focused on interactive computing. The others, CHP, dummy authenticator, the notebook server, and the spawner are hub parts, and we'll talk about them in more detail in the following slides. So, what do we get if we put the hub in Jupyter? Yep, you guessed, we get JupyterHub. So let's go back to the basics and start with the very old school definition. So JupyterHub is a way to provide Jupyter notebooks to multiple users from their browsers on a shared infrastructure. So no more working alone, I guess. In order to allow multiple users, we need to have an authentication service so that we make sure that everyone is who they say they are. So the hub has to have an authenticator. It also needs to be able to create single-user notebook servers on demand. For this, there's an object called the spawner that knows how to do exactly that. Then it needs a mechanism to map and route each user to their own notebook server. For this, there's the proxy. Let's see now how all of these components fit into the high-level JupyterHub workflow. We have a JupyterHub user trying to get access to their notebook server. For this, the first thing to do is to open up their favorite browser. Then in the browser, they need to copy the URL where their hub is running. The user request will first hit the proxy, which, if this is the first request of the user, will route it to the hub. So the proxy is the only publicly accessible endpoint into the hub. The first hub component it interacts with is the authenticator. The authenticator checks with the user database or with an external authentication service like GitHub or Google or Bitbucket or any other, whether or not the user should be allowed access into the hub. If everything is fine, then the spawner will get a response to create a notebook server for this user. After this, the hub notifies the proxy to add a routing rule from this user to their recently created server. Once the server is running, accessing /user/username will connect that user to their notebook server. The single user notebook server will then double check with the hub if any changing to the notebook should be allowed. So you can change pretty much every main component of JupyterHub and still be able to call it JupyterHub. You can choose the interface you want to be shown when accessing your single user notebook server. So we already said JupyterLab or the classical notebook interface. You have lots of authenticators to choose from. Some examples: native authenticator, first use authenticator, PAM, or other external services. Based on the infrastructure your hub is deployed onto or your particular use case, your spawner can be anything from Docker spawner, kube spawner, or batch spawner, and others. Then you have services that you can plug into your hub and provide additional functionality, like the idle cooler. Last but not least, you can go with the default hub proxy, CHP, or choose to use JupyterHub traffic proxy. So, JupyterHub traffic proxy. This was my Outreachy project and my first interaction with JupyterHub. I believe it is worth describing it a bit, since I think this can serve as an example for how easy it is to extend and build on top the hub's architecture. First, as I mentioned in the workflow slide, the proxy is the only public entry point and the first unit that manages your single user notebook server spawn request before it gets sent to the hub or to your notebook server. Its main purpose is to be the hub's map. It holds a routing table that knows how to link a username to its associated notebook server. JupyterHub traffic proxy in particular can store this table in a TAML file or in a key value store. So, traffic proxy implements the JupyterHub proxy API, and it differs from CHP in terms of routing table storage. CHP is a single process, Node.js proxy, that stores the routing table in memory. Because of this, CHP is easy to install and run, and this makes it a fine option for some cases. However, because you can only run a single copy of the proxy at a time, it has its limitations when used in a dynamic, larger scale system. So this is why the idea of a proxy using Traffic emerged. Traffic is a Go application, and it consists of a single executable file that you just download and run. Because it offers the possibility to store the routing table in a file, and more importantly, in a key value store, it makes it perfect for large-scale systems, because it can provide high availability this way. So JupyterHub traffic proxy is successfully being used in the Littlest JupyterHub distribution, but for a different reason. Before this proxy, TLJH used traffic as an edge proxy that provided Let's Encrypt support, and then CHP to do the routing. But now it uses traffic TAML proxy, a proxy that serves both requirements. The plan is to leverage the high availability in Zero to JupyterHub with Kubernetes, and there were already some attempts that have been made in this direction. However, there are still a lot of moving parts, and more time, effort, and research has to be put into this before making any decision on how to proceed further. So I'm sorry to disappoint you on this one. Let's go back to the idea of implementing your very own custom proxy. For this, the docs offer a starting point on how this can be achieved. And from a design perspective, it's really not that hard. So first thing to do is to subclass JupyterHub's base proxy class. You will find there all of the methods you need to implement and the instructions on what the hub expects at the end. But roughly, a JupyterHub proxy must implement methods on how to start and stop the proxy, so the hub will know how to do this. This is needed for the cases where you choose your proxy to be entirely managed by the hub. Then you need to define how a route gets removed for when a user is deleted, for example, and how to actually add a route from the user to their notebook server. In case something changes in the JupyterHub state, it also has to exist a way for the hub to retrieve all the routes from the proxy, kind of like a get back in sync mechanism. So that's it, and it's really easy, right? Okay, so apart from writing your custom proxy, one can also write their very own authenticator or spawner. You can find everything you need to know about this in the docs. In fact, JupyterHub Native Authenticator, the authenticator that allows new users to sign up on the system, was created by the amazing Letizia Portela during her Outreach internship. So yay and thanks to Outreach. Okay, so JupyterHub can serve a variety of usage scenarios because it's so extensible and modular. Most of the components available for each hub piece were developed by the community, and you are free to create your own if one doesn't exist already. Or you could extend some of the existing ones and tweak it a little bit so it better fits your needs. The options are endless. So if you want to configure your hub, generate or create a file named JupyterHub config.py and pass that to your hub, and it will know what to do with it. It will allow you to change and configure the hub's main components and even more. This file is the gate into JupyterHub configurables and your most powerful superpower. So we know now how JupyterHub works, what are its main components, what and how to change them. Let's see now what's the thing with distributions. Distributions aren't necessarily a case of extending a hub, but they still produce a different asset from a system administrator or even developer point of view. Distributions are predefined ways of deploying your hub, meant to be relevant for groups of use cases that share some common requirements. And they are here to make life easier. Deploying JupyterHub independent of these distributions is called deploying it the hard way. This is because, apart from some JupyterHub internals knowledge, some system administration know-how is also needed to successfully complete this task. And though definitely this is not impossible, it will take a bit more time. So currently there are two available JupyterHub distributions. The first one is the Littlest JupyterHub. This distribution deploys JupyterHub inside a single server, a bare metal one or one in the cloud. This means reduced infrastructure maintenance costs and a fair complexity level. This also makes it easy to deploy and requires a minimum to no sysadmin skills. You will have a JupyterHub in a few minutes without even having to SSH into your server. And your users, your students or fellow researchers will get a shared conda environment with their own home directories. However, the cost of being single server is a user number limitation. So TLJH can only support up to around 100 users. But is this really a limitation if one doesn't need more than 100 users? Okay, next one is 0 to JupyterHub with Kubernetes, and it can support lots of users. This is mainly because it deploys JupyterHub on multiple servers in the cloud, and these servers operate under the Kubernetes laws. So this makes it extremely scalable and robust. The infrastructure maintenance cost depends on the actual size of the cluster, which in turn depends on the number of users you want your hub to support. So although much easier to deploy than doing it from scratch, it still requires a bit of Kubernetes prior knowledge and understanding. This is mostly because the underlying infrastructure is a bit more complex than it was for TLJH. So we learned about the configurable and interchangeable parts of the hub and about the hub deployment options. But I would also like to put this a bit in context and give you an idea about the greater puzzle, which is Project Jupyter. UVPanda has a great blog post about this called 99 Ways to Extend the Jupyter Ecosystem on the Jupyter blog. The blog is a great learning resource, and this slide was inspired by it. So, we learned that you can customize and extend JupyterHub. We have deployments that make life easier. Those too can be customized. Then we have something that is actually called extensions. And you can install and create extensions for JupyterLab, for the classical notebook, and even for the notebook server. Not to mention the Jupyter kernels. These are extensible and customizable as well. There are kernels for over 100 languages already. Then IPython magics and widgets, also extensible. So this freedom of choice and extension that the projects of the Jupyter ecosystem offer makes what seems like everything possible. So my first interaction with the hub was through traffic proxy. We know that already. Now, as a contributor in residence, I get the chance to help the maintainers with the everyday things that happen in an open source project. So here we have things like improving the documentation, writing or restructuring the tests, writing blog posts, writing code, fixing bugs, or just offering support to other people. One of the things that I'm most proud of is configuring the welcome bot for the JupyterHub GitHub organization. The bot welcomes contributors that opened issues or pull requests for the first time in a JupyterHub project. It also congratulates them when their first pull request is merged. The entire purpose of this bot is to share the Jupyter love and appreciation to all of the new contributors out there that were able to volunteer their time into making these projects better for everyone. So if you met the bot already, I hope you liked it. Drawing an illustration for the bot was inspired by the Turing Way and their great Scriberia illustrations. So thank you for being an inspiration. If it's not obvious already, the most important puzzle part of JupyterHub and Jupyter in general is the community. Maintainers, contributors, and users alike. They are not that different, and very often those three circles, those three groups interlap. Interlapping, they create what we call the Jupyter community or the Jovians. Okay. Some takeaways. The bottom line is that even if two Jupyter hubs look different and even if they are tuned to do slightly different things, at the end they serve the same purpose, and that's the Jupyter magic. This, of course, wouldn't be possible without a strong community powering all that magic. Thank you so much for watching this talk and for being a Jupyter community member. Enjoy JupyterCon. Bye!